verifying trig identities using advanced identities. The more identities we learn, the more tools we have to work these kind of problems. So here's an identity. We want to follow our standard verifying techniques. Let's see. I need to pick one of the sides to start with. I'm going to start with the left side because what I notice is, oh hey, cosine 2 theta. And I have identities now for rewriting that. Now, the cosine double angle identity is a tricky one because there are three versions of it, and so the question becomes, well, which of the three versions should I use? And sometimes you try something out and it doesn't work, so you try something else. I can try to get some clues from looking over at the other side. I mean, I know I'm supposed to make this left side match the right side. I'm going to end up with a 1 here at some point, and I'm thinking, well, the only way that's going to happen is if maybe there's a cosine squared theta on the top, and somehow cosine squared divided by cosine squared would make a 1. And so when I go back to look at those identities, it makes me think, well, maybe I should use this middle one because it does have a plain old cosine squared theta as part of it. So that's what I think I'll try. I'll replace cosine 2 theta with cosine squared theta minus sine squared theta. Okay, we've used our double angle identity. And then since I do just have a single term down here at the bottom, I think I will distribute this into each part. So I will have cosine squared theta over cosine squared theta and sine squared theta over cosine squared theta. And then I think we're done. Here's that 1 that we knew we wanted to make, and sine squared over cosine squared is just tangent squared. And we have it. It's an exact match. We've verified our identity. Let's try a second example. This one looks a little bit more complicated. Same directions, verify the identity. Of course, I'm always looking at both sides. That sine 4x catches my eye. I'm going to have to do something with that, I'm sure. On the right side, what could I do there? The thing that pops out at me that I could do is a little bit of factoring. In other words, I could factor out the GCF. Each term here does have one sine x in common and one cosine x in common. If I factor that to the front, let's see, from the first term, I have a couple of cosines left, cosine squared, but no sine because I took that. And then I have a couple of sines here and no cosine because I took that. So at least that looks a little bit nicer. I can see the pieces a little bit easier. Let's concentrate though on the left because I think most of our work is going to come there. You're looking at sine 4x. You're thinking, well, we don't have an identity for that. And you're right. This is where sometimes, again, you have to be a little creative. Yeah, I don't have one for sine 4x, but 4x is really the same thing as 2 times 2x. In other words, 4x is itself a double angle. So I could apply the double angle identity for sine. Let's refresh our memory as to what that is. Always put scratch work off to the side somewhere. So sine 2 theta is 2 sine theta cosine theta. Well, I'm going to apply that to my left side here. Here's my theta. This red box is my theta. Sine 2 theta. Okay, so I can replace that with the right side of the identity, which is 2, times sine theta. The red box is my theta, so sine 2x, and then cosine 2x, all divided by 4. I do have some simple cancellation that happens. 2 goes into 4 twice. Okay, where will I go next? Well, now it seems a little more obvious. All I'm left with here on the top, I have a sine 2x. Well, that's a direct application of the double angle identity. And then I have a cosine 2x, and I have an identity for that as well. So let's see, sine 2x, that's just what we have written right here. That's just 2 sine x cosine x. That's being multiplied by cosine 2x. And remember, that's the one where I have 3 choices, and so I'm always having to kind of decide, well, which one would be the best one to use. Glancing over at the right side might give me a clue, and of course what I see over here is cosine squared x minus sine squared x. Well, that is exactly this middle version with an x instead of a theta, but cosine squared x minus sine squared x would be cosine 2x. So let's use that one. I'll need a parentheses here. So cosine 2x is cosine squared x minus sine squared x. And then I still have that 2 on the bottom. And then I think we've got it. After you cancel the 2's out, everything that I have left is what I have on that other side. And so we did it. We verified this identity. Thanks for watching.